Hello, I hope you are doing well. Today we'll be talking about the weak-strong regimes in M-theory on a special class of Calabi-Yau fourfolds. So, testing this one-plant conjectures in the context of string theory on a Calabi-Yau threefold has led to interesting results, both mathematically and physically. In this work, we'll generalize the fibration structure to Calabi-Yau fourfolds with finite volume in infinite distances, and we'll see its implications on the effective field theory. So the asymptotic weak gravity conjecture is a refined version of the weak gravity conjecture, which in its most basic form states that there should exist in a theory of quantum gravity at least one particle whose charge to mass ratio is greater than the charge to mass ratio of an extremal black hole. Many refinements of the conjecture has been proposed. For example, the tower weak gravity conjecture. And among these refined versions, we find the asymptotic weak gravity conjecture, which focuses on infinite distances in the moduli space, where towers of light weakly coupled states are present and expected to satisfy this relationship. So if we start from an 11D supergravity action with gravity and the gauge fields, we get in 3D the following action with gravity, scalar fields, and gauge fields arising from reducing the three form in the Calabi-Yau threefold. So finite volume, so for gravity to remain dynamical, the volume of the Calabi-Yau should remain finite. And to do so, we need to parameterize the Kähler form of the Calabi-Yau threefold as follows, with these components representing the volume of the base and this part representing the volume of the fiber. So we can have the volume of the total Calabi-Yau manifold to satisfy this relationship. And by shrinking the fiber and expanding the base, we get a finite volume. So these constraints, depending on the value of alpha, gives us three possible fibration, either a T2 fibration, a surface fibration with the surfaces being either K3 or T2, or a volume fibration with the Calabi-Yau fourfold admitting a Calabi-Yau threefold as a shrinking fiber. If we allow both the fiber and the base to expand, we get different results, among which we cite K3 cross K3 with a duality symmetry given by lambda, which exchanges 1 over lambda, and giving a Calabi-Yau of the form the fiber shrinks and the base expands in such a way that the volume of the Calabi-Yau remains finite. So if we take a curve in a Calabi-Yau of the form K3 cross K3, this will give us gauge couplings given as follows. So this in the expanding base or in the expanding K3, and this one arises from the shrinking K3, and we get weak and strong gauge couplings that are related by the operation lambda 1 over lambda. These relations will allow us to test the asymptotic weak gravity conjecture, since since the charge to mass ratio of BPS states is protected by supersymmetry along the moduli space, and thus we can test the asymptotic weak gravity conjecture and even the minimal weak gravity conjecture.